The CFS model upgrades, suggesting imminent coupling with the ocean and the atmosphere. Should you believe it? I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, July 16th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. If you want to donate a little money, you can. Use the special thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Big Ben, thanks so much. Sammy and Jason, all of you, I appreciate it. Thanks a lot. And with that, let's get to work. We'll start by looking at significant wave heights for the South Pacific Ocean, and we don't really see anything. South America here, Chile, Peru, New Zealand, Australia, the Ross Ice Shelf pushing further to the north, but still smaller than normal for this time of year, given warmer than normal temperatures in the ocean and the atmosphere. We see no seas really at even 20 feet aimed off to the northeast, so the lockdown of high pressure in the South Pacific Ocean appears to still be in play. We'll quickly check current conditions starting Northern California. Point Reyes buoy number 029. We're looking at all the energy that's hitting this buoy all the way up from 33.3 second period, super long energetic swell energy, which there is none, all the way down to 5 second period pure wind chop. We see the height relative to the period strongest in about the 8.5 second period range, pure wind swell, and then a little bit of dribbles out here somewhere in the 13-14 second period range. That's probably southern hemi swell left over. Primary swell 6.5 feet at 8.6 seconds from 318 degrees. That would make surf at about head high or something like that. And then the secondary swell 1.7 feet at 13.1 seconds from 200 degrees, making surf at about 2 feet, thigh high, something like that. Going down to Southern California, Point Loma, South Buoy, number 191. Do the same analysis here. You see mainly just the southern hemi swell in the 14 second period range, and then some wind swell mixed in the 9 to 11 second period range. Primary swell 1.8 feet at 13.4 seconds from 204 degrees, so thigh high, maybe waist high surf. And then the wind swell 2.3 feet at 10 seconds, and again surf at about knee to thigh high. And then finally over to the south shore of Oahu, Barber's Point buoy number 238. Really nothing going on, a tiny little bump of energy at about 11 seconds, and that's it. Primary swell 1.7 feet at 11.6 seconds from 166 degrees. That would be 2 foot surf, or again, knee to thigh high, and that's about what the surf is. So let's go back in time. We're looking at significant wave heights for the South Pacific Ocean. We're going back to Monday, the 3rd of July. Little gale developed here southeast of New Zealand, produced seas right about there. What was that, 25.8 feet. These are the highest seas over this entire domain. See if we got any readings any bigger that are actually aimed to the northeast. And there we go. Yeah, there was about a 26-foot reading, and there we go, 27 feet. This was on Wednesday, the 5th of July, and this system sort of tried to keep going into Thursday, but faded out. And that swell has already passed Hawaii, and that is the last little dribbles of southern hemiswell that are currently hitting California today on Sunday, and pretty much should be gone after that. We're looking into last weekend now. Really nothing happened. We're looking for any seas. Yeah, a tiny little patch right there, maybe 28-foot seas occurred on Wednesday the 12th, but disappeared as quick as they came. Expected to get literally no surf from that. It just wasn't big enough of a fetch area. It didn't last long enough. Then we're going into Saturday, and now today, still nothing of any interest. So the Hindcast models have been extended. They go back now 2 weeks. You can get to these by going, click on the nav bar at the top of the site, stormsurf.com, hit the Waves section. You'll get to this page. You scroll down here, and high fidelity models for the North Atlantic, South Atlantic, Pacific. These little white buttons here, click those, they'll bring up the wave model that goes back 2 weeks. And also the surface level pressure models, same way. You go up here to the top, you go to weather models. Let's see if we can pull this up here real quick. Models, weather. You'll get a page that looks very much like this. You'll see the white icons. Click on those, and you can go back 2 weeks. So you, even after a swell's hit, especially southern hemi, you can go back and do a little bit of research for a day or two after the swell's gone to see what caused it. So is there anything in the forecast? We're going to start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they form, help direct their track. We're looking for a trough, a push in the jet to the north in the southern branch of the jet stream. Well, here's the northern branch of the jet stream. Pretty strong. This has been the pattern of late. Just most of the energy in the northern branch, that does nothing to support storm development. Running on about the 30 south latitude line the whole way across the Pacific, pushing into Chile. The southern branch down here is pushing in, the Ross Ice Shelf is about 65 south. It's pushing over ice. There's a little bit of a trough right here, but if you got a trough where winds push to the north like that, that helps create a counterclockwise or clockwise circulation in the upper atmosphere, and in the southern hemi, that's the sign of low pressure. Also does the same thing down at the ocean surface. And low pressure, of course, if it's strong enough, generates winds. If they're strong enough over a large enough area aimed in your direction, create seas. Seas, as they radiate away from the fetch area, eventually groom themselves out and turn into swell. Swell, when it hits your beach, turns into surf, but we don't see any of that at the moment. So we'll go into Monday. Again, we got the opposite of what should be happening. You have this split jet stream with half of it down here, half up here. Massive high pressure, likely generating at the surface in between, doing nothing to produce surf. And that pattern continues. Now into Wednesday, it almost looks, that's the 19th of July, it almost looks like a little trough is going to forecast, but then quickly the winds just start pushing south again and slam into the Ross Ice Shelf. We're out to Friday now, literally no hope. Saturday and even Sunday, literally nothing. Let's see if we can get it out any further. 180 hours out, the pattern still looking bad. We think we know what's going on, and we think it's attributable to the MJO, but we're not going to get into that right now. Next up, surface level pressure, surface level winds. We don't expect, given what we've seen in the upper atmosphere, we don't expect to see anything develop down here at the ocean surface. We're looking for winds at, I'll be generous and say 40 knots aimed off to the northeast. And all we see is, well, it's 35 knot winds, but they're all almost over the Ross Ice Shelf and pushing towards Antarctica. Same with this other fetch under New Zealand on Thursday and Friday the 21st, all falling south. Cut off low here, but those winds too, aimed south, really can't get to be any worse of a pattern. And there we are a week out, still no signs of swell production in the southern hemisphere. So we'll go take a look at the effect of those winds on the ocean surface, so we don't expect there to be much, if anything, going on. Again, we're looking for seas 28 feet. That'd be like this dark red aimed off to the northeast, and we're not seeing it. We do see fetch, we do see seas, but they're all crashing right into the Ross Ice Shelf. There's that cutoff low again, all its energy aimed south, and we're out a week, and really nothing to speak of. Talk about summer doldrums, this looks like it. So then we start looking for any signs of wind swell, all right? And this is the surface level pressure and wind forecast model. Why here? California, Northern California, right up here. We see a fetch. We see high pressure is what we really see in the northern hemisphere. Winds circulating clockwise around that in the northern hemisphere, creating a pressure gradient with heat low pressure inland over California, generating 20 to 25 knot north to northwest winds along the North California coast, producing small waist-high type wind swell. Also notice a tropical system, Hurricane Calvin, but is probably tropical storm strength by this time. You can watch its path. We'll get into the details here in a minute. But as we get into Monday, Tuesday, the gradient holds off of Northern California, breaks up a little bit Tuesday night into Wednesday. You can see the effects for Hawaii here. We'll get into that in a minute. But as we get into Thursday, wind swell relative to California continues. Nothing huge, small, and northwest winds along the coast. Again, this is just feeding that upwelling pattern. The colder the normal temperatures off California, you'll see it when we get into the MJO and El Nino discussion. The pattern is not stopping. I mean, it's just locked in. If anything, it's getting worse now, not better. This is all indicative of the remnants of La Nina holding in the atmosphere. La Nina typically enhances high pressure in the Gulf of Alaska. That's exactly what we're seeing. It's just been perpetual. It hasn't stopped. And we also are running about 6 weeks behind normal. I mean, normally you'd say we're like in the midst of summer right now, but we're really, for all practical purposes, atmospherically in the, we'll say the very beginnings of summer. Anyway, we're out to Sunday, the 23rd of July. High pressure holds. Yes, you see low pressure in the Gulf. It still can't even just cut a hole in the high pressure. So the upwelling pattern, the local wind swell continues and trades for the Hawaiian Islands. Here's the track for Hurricane Calvin. Winds as of Sunday morning, the 16th, were 65 knots, but then by now they're down to, looking around the microphone here, 55 knots, slowly fading. The remnants of Calvin still a tropical storm, minimal tropical storm force winds, 35 knots, forecast moving. This track has moved a little bit further to the north than it did this morning, over the southern tip of the Big Island, Hawaii, but accelerating. You notice the distance between each of the readings here starting to pick up, and then down to tropical depression status. Let's see, that would be on the 19th or Wednesday, sometime Wednesday or early Wednesday morning, and then out of there as we get later in the day. And we can see the GFS model. So Hawaii is right here. Here's Calvin. Put this into motion. You see it approaching. And as we get into Tuesday morning, winds start picking up from the east-northeast for the Hawaiian Islands. 20-knot winds pushing into the Big Island, maybe sometime Tuesday night. By Wednesday morning, 35-knot winds along the east shore of the Big Island, but pretty much 20, maybe 25 knots out of the east-northeast for the other islands, generating wind swell. And then by, about 7 o'clock on Wednesday, theoretically, the Calvin all but gone for the Hawaiian Islands. So it would be Wednesday, late evening, probably would be the worst of it for most of the islands other than the Big Island. And looking real quick at temperatures in the Sierra, the snow melt continues. We're at the intersection of the Pacific Crest Trail and Tioga Pass Road. Tioga Pass Road is still closed due to damage just past Olmsted Point. I've heard rumors, though, that hopefully they're going to have the road repaired, and maybe by the end of this month, July, it will be open. There is still, though, a lot of snow up in the higher Sierra. Was up there, did a survey just the past 2 days. North-facing aspects, there is still heavy, pretty much continuous snow from about 9,500 feet, maybe 9,000 feet in some place and above. Hiking in higher elevations, pretty much not possible this time unless you're some sort of a hero or have a death wish. The temperature regime, here we go. This is the snow level or the freezing level forecast. Anything that's red is liquid precipitation, so it's liquid above 14,000 feet. So steady snow melt expected, no cold temperatures, and the melt will continue. Good news for the water table, good news for the lakes. They're all full. Lakes that 2 years ago were bone dry are full to the brim right now, and it really is beautiful to go up there and see it. So if you follow me on Instagram, I'll be posting some pictures over the next day or two, and you can go check it out. So what's going on for surf? We'll start in Northern California, Half Moon Bay. We see surf heights in the 4 to 5 feet sort of thing. But if you get into the details, that's actual surf height. This is the wind speeds, all out of the northwest. Not too bad near the coast. A little bit rougher further out at sea. But we see swell heights in the 5 to 6 to 7 foot range, but period all in the 8-second period range. So just pure northwest local wind swell. At least we have that given the lack of southern hemiswell. For Southern California, not so good. Sea heights in the 1 to 1.5 foot, surf heights in the 1 to 1.5 foot range. Swell heights 1 foot to 1.5 foot at 9 to 10 seconds. Pretty much all wind swell, so not a whole lot there. Then for the south shore of Oahu, surf heights 1.5 feet. You see the wind speeds definitely picking up, though, here somewhere in the Wednesday time frame, up to 28 knots out of the east-northeast. And swell heights 1.5 feet at 8 to 9 seconds, something like that. Calvin really not going to do a whole lot for the South Shore. It'd be exposed east-facing shores, mainly of the Big Island and Maui. Maybe a little bit local wind swell on the east shore of Oahu, but we're not showing it here. All right, let's go take a look long-term. What's going on with the MJO, the Madden-Julian Oscillation, and the El Nino Southern Oscillation? These two weather oscillations are the best predictors for long-term surf and weather in the Pacific Ocean. First off, we're looking for signs of the active phase of the MJO, the Madden-Julian Oscillation. It's this periodic weather oscillation that rotates around the planet from west to east on the equator. If you like this, the active phase of the MJO on one side of the planet, inactive phase on the other, polar opposite of each other. The active phase is the one we want. It feeds energy to the jet stream. It's like a low pressure system. Sucks warm, moist energy off the ocean surface, thrusts it way up into the atmosphere. That energy gets caught by the jet stream, fuels the jet stream, makes it stronger, and then a stronger jet stream is better at forming troughs and then fueling storm development. Likewise, the inactive phase of the MJO is like a high-pressure system and does the exact opposite. It starves the jet stream for energy, the jet stream splits, and then you get no storm development. Notice when we were looking at the Southern Hemi jet stream chart, it was split, has been well split, and is forecast to remain split for a week. This is all a function, we believe, of the MJO, or for that matter, the lack of any active MJO pattern. So let's try to bear that thesis out. We're starting by looking at winds. So the MJO, also the active phase, when it's over the Pacific, it tends to dampen trade winds where the MJO is positioned in the Pacific. If the MJO is strong and active, and over the far west Pacific, it'll dampen those trade winds, or if nothing else, actually reverse them. Instead of blowing east to west, they'll blow west to east. That motion or that energy, if it lasts long enough, and typically the MJO hangs over the Pacific about 5 or 6 weeks, it will take warm water that's pooled up in the West Pacific, start pushing it east. That warm water will follow the thermocline down about 150 meters in the ocean, and then start tracking across the Pacific as a ball of warm water known as a Kelvin wave. If you have successive active phases of the MJO, you can get successive Kelvin waves, and that can redistribute warm water from the West Pacific to the East Pacific. And that warm water, eventually, those Kelvin waves, as they impact Ecuador and the Galapagos Islands, will erupt to the surface. They will start creating evaporation there, and that will change the circulation. If there's successive Kelvin waves, it'll change the circulation of the Pacific, the upper air circulation, the Walker circulation specifically, and help usher in El Nino. That is exactly what we're waiting to happen right now, is for the Walker circulation to change. And what that means is the ocean and the atmosphere become coupled. That fuels the El Nino development machine, and then you're off to the races. We're not there yet. All right, so we're looking for signs of the active phase of the MJO. This is the West Pacific here. This is the East Pacific here. This is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. They have wind sensors on them. Remember, the active phase of the MJO dampens trade winds, so we're looking for some signs of dampened trade winds. Well, we're just looking at the arrows, strong out of the East and the East Pacific, no help there. Pretty strong in the Central Pacific, but as we get to the West Pacific, notice the trade winds, they get to about 170 east, and then they just die. That suggests that something is going on over here. Let's dig a little deeper. It's not the actual wind speeds, it's the anomaly, the difference from normal for this time of year. These strong east winds here in the East Pacific, yeah, they are a little bit stronger than normal. Over the Central Pacific, pretty much normal, or if anything, notice these little bit of westerly arrow thing going on here, suggesting maybe the active phase of the MJO, or maybe even a El Nino-ish like base state is trying to get established in the West Pacific. Let's go dig deeper. So what's the forecast for the next 2 weeks? This from the GFS model. Now this is the whole planet. This shows you the east-west component of the wind, or the east component of the wind, or the west component of the wind. Okay, the blues are easterly anomalies. Think of that as the inactive phase of the MJO, enhanced trades. The yellows and reds are westerly anomalies, the opposite of trades. Think of that as the active phase of the MJO. Now this is the whole planet on one chart, and all we're really interested in is a small area in the West Pacific on the equator, the area we call the Kelvin wave generation area, 5 degrees north and south of the equator, from as far west in the West Pacific as you can get to about the date line, maybe 10 degrees over. So as far west as you can get is about 125 east to about 170 west. This box right here, that's the forecast. This is what has been occurring over time. So you see easterly anomalies in that area. Looks like the inactive phase of the MJO, but about 2 days ago, westerly anomalies started building. They're supposed to hang on for 4 days, maybe take a break for a day or two, then come back stronger, little bit bigger footprint. Now, this is interesting. This is the GFS model. There's 3 other models, the CFS, the CM model, and the ECMWF. All of them are suggesting westerly anomalies stronger than the GFS, and all happening somewhere between now and maybe a week and a half from now, depending on which model you look at. Go to Instagram, follow me there. I actually posted the output of those 3 models, but I don't have access to it to be able to get it to update every day. It's not on the site. It's just wherever I can grab it and share it with people. So this is the least friendly of the model runs. All the others suggest a significant Kelvin wave westerly wind burst active phase of the MJO cycle is either starting or going to be starting in the next week. Let's look at another dynamic or component of the active phase of the MJO. That would be outgoing long wave radiation, OLR. Now, the fancy words for cloud cover. If the active phase of the MJO is a low pressure system, well, low pressure causes rising air, generates clouds. So all this does is say, on average, is it more cloudy or less cloudy than usual? If you're in the blues, the negative readings here, that'd be less sunlight reflecting off the ocean surface. That means more clouds. So this is the statistic model. Oh, and let's get oriented here. South America, Central America, Hawaii, New Guinea, the equator running right there, date line right there. So the Kelvin wave generation area is roughly right here. Dead neutral pattern per the statistic model, continuing 5, 10, 15 days from now. Now the dynamic model, a little bit more favorable, suggesting a moderate active phase of the MJO setting up starting in about 10 days and pretty well in control 2 weeks from now. So the GFS model compared to the ECMWF and some of the other models, a little bit later in developing this active phase of the MJO. The other models suggest maybe happening in the next 5 to 10 days. Next up, phase diagrams for the same two models, the statistic model here, the dynamic model here. How do you read these charts? Well, the MJO moves from west to east, from the Indian Ocean to the Maritime Continent, that's like Bali, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is, so over the Maritime Continent right now. The forecast and if the dot is inside the circle, it's considered to be extremely weak. What you really want to see is the heavy dot somewhere up in here, but we're nowhere close to that. 3 different forecast tracks for the statistic model have the active phase somewhere in the west east Pacific 2 weeks from now, and exceedingly weak. The dynamic model, though, suggests the active phase still weak, but moving into the West Pacific and just sort of noodling around and not moving nearly as fast as these models suggest. Here's the upper level model. It's a statistic model. It shows areas favorable for precipitation. Yellows and oranges here, that would be dry air, the inactive phase of the MJO. The good phase, the active phase, is green here, wet air. And let's get ourselves oriented. South America, Central America, New Guinea, the equator, the date line there. This goes out 40 days, 5 days each panel. So we see the active phase of the MJ over the West Pacific today, and moderately strong, supposedly, and then slowly pushing off to the east, pretty much gone out of the Kelvin wave generation area. That would be like right in there by the end of July, with the inactive phase coming in, taking over the whole month of July, pretty much to the end of August. But the CFS model paints a very different picture. All right, so let's get ourselves oriented. There's past performance here. The solid black lines are the active phase of the MJO. The dotted ones, the inactive phase. Notice the blue, and this is the east-west component of the wind. Easterly anomalies, inactive phase of the MJO are the blue. Westerly anomalies, the active phase, are reds. Okay, we see, and this is past performance here. Here is the forecast down here. Kelvin wave generation area starts the far West Pacific 125 east, going to about 170 west, so a box right in there. So this shows today's weak westerly anomalies, inactive phase, pretty much out of the picture from the Kelvin wave generation area, according to this rendering of the model, with westerly anomalies trying to get a foothold here for the next week to about a week and a half. Active phase, the solid contour active phase. Now the West Pacific starts at 125, so this is over in the Indian Ocean right now, bound for the Pacific. But as we get into the end of July, there's a completely different picture than what we saw in the last model. Strong westerly anomalies, active phase of the MJO setting up, and we're off to the races. Now also note, how long has it been since we've had any kind of real swell? It's been a while. The swell, though hard to trace as it is, this is the last active phase of the MJO that occurred in May into maybe the first couple of days of June. And that syncs pretty well with the last time we had any real decent solid surf, not even solid, but just a moderate run of swell in California. It was pretty much the whole month of May into the early part of June. And since then, things have just shut down because we've been dominated by the inactive phase of the MJO. We hope that you have used this time to go take care of business, because theoretically, once the active phase gets established here in the latter half of July into August, things might really start looking up, not only for surf, but also for our El Nino, which is developing. And then finally, the 3-month CFS model. This gives us a really good long-term view of what's going on. Now, I know some of you are rolling your eyes going, yeah, we've been waiting for the CFS to tell us, it's been hinting and teasing us. I think the last time we had this discussion, July 13th was the due drop dead date. So that would be right around in here. Sure enough, just the very start faint westerly anomalies are developing. The forecast, you're just eyeballing this. Oh, and this is the forecast in this one. Past performance is down here. And let's get ourselves oriented. Far West Pacific starts 125 east, so here, ends at about 170 west, so here. So this box right in here is the sweet spot. And this model, along with a whole bunch of other models, is saying the MJO and El Nino is supposed to wake up somewhere in mid-July. Look at this. It even has decent westerly anomalies over a small area starting in the next week. So we are very close to, theoretically, in this window where magic's going to happen. We're going to overlay the MJO. Solid contour is the active phase of the MJO. Now this tells the picture even better. The dotted contour, inactive phase of the MJO. It's saying the inactive phase of the MJO is still pretty much in control. Active phase really doesn't get a good foothold in the West Pacific for about another 5 days. And as soon as it does, the westerly anomalies start picking up and build stronger and stronger and continue non-stop into September and even past almost through the month of September. Why is this important? Well, we need Kelvin waves. If you want to get El Nino, you got to have warm water. We have lots of warm water. We're going to get into that. And it's over in the East Pacific, and the machine is all set up for El Nino to get started. What we need is a continued supply of warm water pushing into the East Equatorial Pacific for the fall to really supercharge El Nino, and we need the atmosphere above the ocean to realize that there's all this warm water in place and to start feeding it. As the atmosphere gets coupled with what's happening on the ocean surface, the two of them will start working together, feeding this Kelvin wave production machine, trade wind reversal machine in the West Pacific, and that in turn feeds the jet stream, and then once you have a strong jet stream, you start getting storms. So right now, I think we are in the dead zone between the end of La Nina and the hangover of La Nina in the Pacific, but not the start of El Nino yet. The rest of this video is about talking that point and trying to prove it. Anyway, active phase of the MJO setting up for the next 2 months over the West Pacific, right where it needs to be, producing lots of westerly anomalies. Now, here's the big upgrade from the CFS model. Okay, and you're going to go, well, what is all this mess? All right, so let's get oriented here. The dotted contour here, in fact, I'll turn it on and off just so you see what's happening. The dotted contour is a high-pressure bias. It is the La Nina signal, if you will. Notice it's pretty much south of Hawaii, or was south of Hawaii. Now it's pretty much over California, right where we have those northwesterly winds raking down the coast, creating upwelling, and steadily getting thinner and thinner. The solid contour is the low pressure bias, 120 east, that's over the maritime continent. The date line's right here. So the Kelvin wave generation area is, again, this box like right in here. The big upgrade is, for weeks, this model has been saying this third contour was pretty much, it's done and it's over. Now all of a sudden today, boom, the third contour not only starts building in earnest, but growing in size. This is what one would expect to see if you were in a building El Nino situation. And that in turn helps fuel the westerly anomalies, which fuels the Kelvin wave generation machine, which fuels the jet stream and the coupling of the ocean to the atmosphere. In fact, I'm going to take this stuff away here. This bit right here, this starting right here, is the CFS trying to tell us that it thinks that the ocean and the atmosphere are going to get coupled in the next couple of days. And what that means is the Walker circulation is going to change. And I'm not going to get into all the details of the Walker circulation. We've had some discussion about this in the comments section of the video. You can go read. This is just last week's was the biggest one. And the discussion is around when will the ocean be coupled with the atmosphere. And the models have all been hinting somewhere around July 13th. Now we're slipping maybe a couple of days, but the latter half of July is what it looks like that's all going to happen. Assuming that happens, we could be off to the races. All right, so what's going on down in the ocean at depth? We want to understand the balance of warm water and Kelvin wave production. Where is the warm water at? All right, so this is data from the TAO buoy array, the series of buoys strung across the equator used for monitoring El Nino. These little X lines here are the anchor lines on those buoys. The X's are actual sensors on the anchor lines. Those sensors relay data about temperature. You use a model to fill in the gaps, and you get a profile of the warm and cold water balance across the Pacific. West Pacific here, East Pacific here. 30-degree anomalies, 30 degrees centigrade, very warm water. Building in coverage, I think, it was about 180. Now it's at about 178 west. The 29-degree isotherm, it's been holding somewhere between 58 and 161, so it's given up a little bit this past week. 28-degree isotherm as well has given up some. A lot of this attributed to no active phases of the MJO, right? Got to have active phases to have west anomalies, and if you get west anomalies, that's what produces Kelvin waves. If you don't have active phases of the MJO, the warm water pump shuts down. That's exactly what has been happening now for the past 4 to 6 weeks. All right, 28-degree isotherm, backtracking a little bit. Fortunately, the 26-degree isotherm still solid, pushing into Ecuador. So the El Nino base state, at least looking at this, looks pretty good. But let's look at the anomalies, the difference from normal for this time of year. All right, now the good news is, well, we do see some cold water here, but it doesn't appear to be of any real interest at the moment. We see lots of warm water in the East Pacific, 2 degrees above normal temperatures from, what is that, 150 west on into Ecuador. This is a couple of months' supply of cooking warm water. What we don't see is warm water building back here because there's been no active phase of the MJO, nothing to take the warm water that's over the maritime continent, squeeze it into the Pacific. So it feels like atmospherically we're falling back into La Nina. That said, we still have a healthy flow of 1 degree anomalies, 1 degree above normal, filling the entire upper reaches of the Pacific. So far, so good, but we need the active phase, and we need another Kelvin wave, and we need it pretty quickly if our El Nino is going to develop into anything meaningful this year. Another version of that chart using satellite data to estimate where the balance of warm water is pretty much paints the same picture. Piles of warm water in the East Pacific and a long tongue of it. Let's see, 1, 2, 3, so that'd be 1, 2, 1. Okay, so 1 degree above normal or more from almost as far west in the West Pacific as you can get, and you see this steady dribble of warm water coming off the maritime continent, falling into the Pacific, but there's no momentum to it. There's no westerly winds pushing it, helping it to build into some sort of cohesive mass that then can start moving off to the east. So all the warm water's there. We just need westerly anomalies driven by the active phase of the MJO to really push the Kelvin wave machine back into gear. Sea level anomalies. This is the satellite data used to build the previous chart. Satellite rotates polar orbit around the planet. The planet rotates underneath the satellite. It maps out the height of the sphere of the ocean. That is, you take out the waves, the wind waves, the tide. And is the sphere of the ocean higher or lower than normal? Why does that matter? Well, cold water at depth, it contracts. It'll create a divot on the ocean surface above where it's contracting. Likewise, warm water expands deep in the ocean like a Kelvin wave. It'll create a bump on the ocean surface. So let's get ourselves oriented here. There's Chile, Peru, Ecuador, Central America right up there, up into Mexico. Okay, that's the equator. That's the, there's the date line right there. Hawaiian Islands are right up here. All right. The oranges and reds are positive anomalies. That means warmer than normal water at depth. We see plenty of that here along Ecuador, the Galapagos Islands, going out almost to the date line. We see bits of it here in the far West Pacific, but now there is this kind of this dead zone, this neutral pattern developing over the date line. All that because westerly anomalies are not taking warm water in the maritime continent, pushing it into the Pacific and creating that Kelvin wave that we really desperately need at this point. And here is the upper ocean heat anomaly pattern. West Pacific here, East Pacific here. Blues colder than normal temperatures. Reds warmer than normal temperatures. Now this goes back a year to last August. Cold water filling the entire East Pacific, warm water all mashed over in the West Pacific, driven by stronger than normal trades blowing from this direction to this direction. This is just like 5 degrees north and south of the equator. So you had massive upwelling in the east, and all the warm water had nowhere to go, so it just pulls up in the west. It continued pulling up, and then somewhere in November we got a little active phase of the MJO, and the winds reversed over here. Took a little bit of warm water, pushed it across. Didn't really do much. But then we got another one in January, a stronger active phase of the MJO. And then in February, another one. And then in March and April, another one. And then May, a really strong one. You can see the buildup of warm water here. And then the MJO, somewhere in about the first week of June, the MJO went to sleep. And notice, no more Kelvin waves. And temperatures slowly neutral, still neutral and a little bit above neutral at depth, but not really feeding this pile of warm water here that needs to be fed if El Nino is to develop. Now, that said, it is not unusual, and we explored this in last week's video, and I think the week before that as well. It's not unusual for the MJO to stall, but it needs to wake up, and the sooner it wakes up, the better to get this Kelvin wave pump and the warm water pump reprimed and get us back in action. Now that's all down in the ocean. What's going on at the ocean surface? The picture is very rosy there, to say the least. All right, this is sea surface temperature anomalies, difference from normal for this time of year. We have South America here with Chile, Peru, Ecuador, the Galapagos right out there. Central America, Baja, California, Hawaii here, the equator roughly right here. The reds and darker colors, much warmer than normal temperatures. This is cooking warm water here, going out to about 105 west, and then solid warm water out to about 135, maybe 136 west, and then lighter warm water from there. The big thing that everyone's been commenting, you can catch it right here, is colder than normal waters just east of Hawaii, all off of California and down into northern Baja. This is the, and notice the warm temperatures here. So what's going on? La Nina-induced high pressure, center of it's hovering right around here. The winds circulate clockwise around there. You can see it just ripping down the coast, creating upwelling, and then off south of Hawaii. As long as you have this one, that sort of acts as a bit of a wall for Hawaii for strong hurricanes coming through, because they're going to hit this colder than normal water and it's going to steal the energy from them, just like our current hurricane is experiencing now. But this here is the clear El Nino signal. So we're like halfway pregnant. We've got La Nina hanging here, not letting go, while El Nino's building like mad, going, I want my turn. The question is it going to get its turn? This is the sea surface temperature change over the past 7 days. We see a couple little pockets of warming here, but basically just a neutral pattern. Temperatures aren't getting any colder. They're not getting any warmer on the equator, other than right in this area here. If we looked at outgoing long wave radiation, in fact, let's do that. This is outgoing long wave radiation anomalies. You can see the blues are cloudier than normal conditions. This suggests that something's going on in the West Pacific from the dateline and maybe even south of Hawaii, right in here. Maybe the very, very beginnings of that Walker circulation change we were talking about. It was all over here for years. It's trying to make progress into the West Pacific, suggesting that maybe the change is coming, but it's not real strong yet. But this here, this warming temperatures in this region, we think one might be some of the outflow from the developing El Nino building up in this area. Two, it could be trade winds reduced and light westerly anomalies like we saw right in the very beginning of the presentation in the West Pacific, starting to warm temperatures here, fueling the production of clouds and cloudiness, and maybe this is a component or an early sign of what's trying to develop. And then finally, the overview again. The clear El Nino signal right here, the clear hangover from La Nina here. In fact, let's go back here. There's one other thing. Notice right here. Sea surface temperatures warming in this area, okay? Meaning that perhaps the gradient is really limited to the area from Point Conception up to about San Francisco or so. Let's see if we can see that here. You definitely see the colder temperatures out here, and down in this area doesn't look as cold as it has been. Still colder, but not as cold as it has been. But still, we end up with this basically cold pattern, warm pattern, battle of the mega forces of nature at work. Who's going to win? Well, we'll see that in just a minute. Sea surface temperature anomaly history. This is the Nino 1.2 region, the area right there where the warmest temperatures are along the Galapagos and Ecuador down into Peru. Temperatures today, 3.179 degrees above normal. So if this was the official El Nino monitoring region, half a degree above normal for 3 consecutive 5 months period constitutes El Nino. We're at not half a degree, almost 3.2 degrees above normal. So a cooking reservoir of warm water here, getting caught by the trades and dragged off to the west into the Nino 3.4 region. So this is the area right on the equator, south of California, from a point south of California out to about the dateline. Today's value, 0.950, almost 1 degree above normal. Again, the cutoff or the beginning of the El Nino threshold is half a degree above normal. So May 28th has started. We've been above that the whole time. Notice we were kind of up, down. We've been stalled, but a little bit at a time. It seems to be creeping up. We just need to get a little bit more. We need the ocean and the atmosphere to couple to feed this machine a little bit more. So here's the zoomed in big picture. Sea surface temperature anomalies for July 15th, right here. Notice the very warm temperatures, the extent, the Nino 3.4 region, what we just looked at, goes from here out to about here. So this box right here. You see the warm waters making headway into it starting at 120, but need to fill it more here. The one thing you do need to notice is notice where the densest temperatures are. They're hugging right up along Peru, Ecuador, and the Galapagos Island. This is what would be called a eastward focused El Nino. The more eastward face you get, the better the odds for precipitation into California in winter months. It also means the center of circulation of developing storms will be further to the east, pushing up more into Oregon and California as compared to a Modoki sort of El Nino, where if you had these temperatures, if it was a Modoki El Nino, a sort of El Nino, they'd be more like out here or even in this region. So this has all the underpinnings of a very strong El Nino, perfectly positioned. The question is, will it last or will it fade? Now let's compare. Let's see if we can do this here. Here we go. And here is the 97 El Nino. Compare that to this one. In fact, here, we'll just fire it right up there. All right, so the 97 El Nino, very warm based, a little bit longer out in this area. In fact, maybe I can, let's see if we can do it this way. Okay, see, pretty close, 97, and this is for July 15th. So we're still on track more or less for the 97 El Nino, which was considered by myself and many to be the gold standard for El Nino development. Now notice the warmer temperatures went out to about 150 west, where this one they only go to about 135. Now you go, okay, well maybe they're not the same. Let's add in some others into this mix. So here is the 2015 El Nino, which was a super eventually it turned into a super El Nino, not as strong as the 97, but a super El Nino in its own right. And compared to 2000 and, 1997, can't really compare them. And then our developing El Nino, well, far stronger than 2015. And then just for fun, I think I've got one more here. Yes, the 2009 El Nino, July 15th, like a shadow compared to what's happening right now. Not even in the same ballpark. So if anything, the closest we've got here, the 2023 El Nino would be with 97. Maybe not quite as strong. And that was a super El Nino. So we're still not in bad shape where we are right now, as long as we get a coupling with the Walker circulation, the ocean, and the atmosphere, and the heat pump gets fired up again. And speaking of coupling, the coupling in the atmosphere of the ocean, we have a measure, an objective way of looking at that, and it's called the Southern Oscillation Index, the difference in pressure between Darwin, Australia, and the Indian Ocean, and Tahiti in the Pacific Ocean. When pressure is lower in Tahiti, and what would be do that? Well, there's two things that could cause pressure to be lower in Tahiti. One, the active phase of the MJO, or two, the development of El Nino. The active phase of the MJO is sort of a 4-week on-off sort of pattern, where El Nino, once it's fired off, once it's coupled, the index will stay negative for months at a time. We're waiting for that to happen. Anyway, right now, today, the index minus 1.97, so basically dead neutral. Okay, and looking back a month, well, this tells the story pretty well. We were deeply negative until almost the end of June, and then the inactive phase of the MJO set up, and all our readings went positive. And now, maybe 3 days is not a trend, but I'm suspecting, given what we're looking at all the models, maybe a light version of the active phase of the MJO is trying to get a toehold in the door in the West Pacific. We're not there yet, but it looks like it's trying. The 30-day average tells you this is your real active-inactive phase of the MJO. Plus 2.51, not too bad, really. Going back in time, well, you see we were down at minus 13 or so, and I think we were even deeper than that at one point. That was during the active phase of the MJO. Now we're in the inactive phase, and all we've gotten to is plus 2.51. That's actually not too bad. Then the 90-day average, that's your El Nino La Nina indicator. Of course, it's a 30-day lag time. a 90-day, 3-month lag time. Today, minus 5.50. Where were we? We're down to minus 7.83 at one point. So we've given up, 2 points? That's nothing. That's really nothing. 30-day SOI, if we were deep in El Nino, this would be down at like minus 20, and this would, or maybe even minus 25, and this would be at minus 20. And likewise, if you're deep in La Nina, this would be up at 20 or 25. We're nowhere close to that. So we're dead neutral right now by all indicators. We think, though, the pendulum is starting to swing in our favor. Here's the 30-day moving SOI all graphed out so you can see it. Positive numbers here. Here's 0. Here's negative numbers. So this would be the La Nina inactive phase range. This is El Nino here. Going back January 2021, the active phases of the MJO are these downward spikes. The inactive phase is the upward spikes. You can see the trend. You just draw a line through it here. We went up at plus 20 by July 2022, sat there, and then mega active phases of the MJO pushed us way down to minus 20 for a minute. Now we're back at near neutral, but I think it's time for this to start falling if the models are correct. And finally, the sea surface temperature anomaly forecast for the Nino 3.4 region from the CFS version 2 model. This is a significant upgrade again from what was happening 4 or 5 days ago. Temperatures on the previous model flattened out or actually dipped negative all of a sudden we're at mid-July, temperatures are at 1 degree above normal. This version, the uncorrected model, says we're heading nowhere but up from here, with temperatures going up to 2.1, maybe 2.15 degrees above normal as we get into November. That's super El Nino status. Okay, do we think we're going there? Probably not, unless some miracle happens in the next week. But this is a significant upgrade, because this was down at like 1.7 degrees maybe a week or two ago. Okay, and then the corrected version, I think this is a little bit too much the other way, says temperatures holding into mid-August and then heading up, moving to 1.65 degrees. So from 1.5 to 2, so 2 degrees and above is super El Nino. 1.5 to 2 degrees, strong El Nino. So this says strong El Nino. Moderate El Nino is 1 to 1.5, and weak 0.5 to 1. Okay, so even the most conservative CFS model says strong El Nino as we get into this fall. So for right now, short term, South Pacific Ocean dead, nothing happening. But why is that? Well, it makes really good sense looking at what's going on with the MJO. It's doing nothing and hasn't been almost the entire month of June. No wonder we don't really have any southern hemi swells of any interest. That said, almost all the models are suggesting the active phase of the MJO is probably developing now, if not within the next week, and that should significantly change the jet stream pattern and everything. Give it about a week or two, and we should be back in business with the South Pacific storm corridors starting to open up. And the thought would be, if it's an El Nino pattern, that the center of the storms and storm development would happen not so much in the east or the South Pacific, like on the far edge due south of California, but it would start shifting more over towards New Zealand. Whether that's going to happen or not, who knows? But if you start seeing the development of storms more there, that's perhaps a good indication that the Walker circulation is changing, the active phase of the MJO is setting up, and El Nino is getting a foothold in the atmosphere. Looking longer term, yes, strong MJO forecast developing here a week to 2 weeks out and going for 2 months after that. That in turn would start the Kelvin wave generation machine, which would start feeding El Nino any more, which would start likely. The Walker circulation is already starting to change now, but that would just feed that machine. And typically as you get into the fall months, starting in August, the Walker thing really does its thing and El Nino starts pumping, and that's what we're hoping to see. We're in the doldrums. Are we going to get there? Is it going to change? Well, we're not sure, but it certainly looks like it wants to, and that it might happen any day now. So stay tuned. If you enjoyed the video, give us a thumbs up. If you have questions or concerns, write up a comment. We'll try to reply. We try to reply all comments. A lot of deep detail here. Don't be embarrassed if you don't understand everything. Most of us don't. Very few of us do. We're all learning together. So give us a comment. We'll try to help you out and reply. If you want to donate, you can do that too. Not required though, but we appreciate it. And with that, we will do this again next week. Same time, same channel. Thanks for watching.